What's going on, everybody? Johnny Bannon here with Trepa Technologies. In today's video, we're going to be going over domain 1.1.2, our second video in our free CYSA course. This is going to go over network architecture. And as a self-proclaimed networking guru, this is going to be a very fun section. Now, again, this is a CYSA certification. So we're not going to go too deep in how to deploy, manage, and monitor these different network architectures like I would in a networking-based course. We just need to understand these architectures and then where we fit in as that SOC analyst, how we protect, how we monitor, how we can be proactive, and how we defend these network architectures from exploits. So let's go ahead and jump right into it. So let me go ahead and get my face out of here, and let's go ahead and jump into it. So domain 1.1.2, explain the importance of system and network architecture concepts in security operations, and we're going to be going over network architecture. So there's the full objectives. Let me fit my face to this screen here. There we go. So the first network architecture we're going to talk about is on-premise. So this is just traditional. This is traditional networking. This is traditional architecture that we'd have been used to if we were working in IT and cybersecurity 10, 20 years ago. This is having our own storage, compute, and network resources locally on our intranet, on our enterprise that we have full responsibility for and that we manage. I'm using that term responsibility because that's going to come back into play. We talk about cloud-based architecture. So when we manage our own on-prem infrastructure, we take the complete ownership of it. Now, obviously, we have vendors we work with, sales engineers, pre- and post-sales, and, if we're working with Cisco, we got Cisco TAC. But as far as availability, security of that infrastructure, that's on us as the organization. Now, when we deploy and manage on-prem, we call that a capital expense because all the cost is up front. That's something that maybe as a cybersecurity analyst you won't have to deal with, but we need to have that knowledge. So when we sit at the table with our DevOps team, our IT team, our cloud team, we understand. So some key notes here. The organization owns and operates all hardware and software, providing complete control over system configurations and security policies. So where do you fit in? As that SOC analyst, we have to make sure that we're monitoring these devices. We're implementing best security practices based on our SOPs, which do become kind of industry dependent, right? If we're in the finance industry, there's compliance we have to be aware of, like PCI DSS. We're in the healthcare industry. We got to worry about HIPAA. If we're working in the government, we're going to have to abide by NIST standards. So we're going to use frameworks like NIST, RMF, CSF as best practice for working in the government to harden and protect and monitor our on-prem infrastructure. Now, typically when it comes to just general technical security, we're going to have kind of a perimeter-based security. What we mean by that is firewalls, traditional hardware firewalls for our on-prem, traditional DLP implementations, things like that. Kind of going back to the old school way we used to architecture out an enterprise. We still have those firewall appliances, filtering. We could have F5 load balancers for high availability. That is in our purview as a SOC analyst. We could have proxies in the middle. If we have a web server cluster, we could have reverse proxies there. So that's and also we're gonna have physical access control, something that we often forget about as cybersecurity professionals because we love doing the technical, applying ACLs, putting together policies, doing our Nmap scans, doing vulnerability scans. Don't forget, your on-prem infrastructure has to be protected physically. We don't want to give anyone access that shouldn't have access to our comms closets or our data centers. Another thing we have to be aware of, if we have a foot at the table or seat at the table when talking about on-prem infrastructure, is power and environmental controls. We have to ensure that we have power for our hardware and infrastructure. We got to make sure we have redundant power, a generator, UPS, maybe multiple lines coming in to provide our power. Placement comes into mind as well. Where do we place our comms closet or our data center? Typically, if that's going to be our main distribution, where our MDF is going to be, where all of our hardware is going to be, maybe sitting on an HQ, we may want to place that to where our demarcation point is. Meaning we want to place the data center closest to where the ISP drop is going to come in. Just things that we have to be aware of. And then physically securing those areas. So on-prem, to kind of wrap it all up, refers to an IT environment where all servers, application, networking, storage, is housed within the physical premise of the organizations, and we have complete responsibility and control. Moving on, let's talk about cloud architecture, which is, I wouldn't even call it, it's 2025. It ain't the new hotness, it is IT now. Cloud infrastructure is IT. That's what we're managing. You go to any job application, the cloud is almost 95% of the time involved at different varying levels, of course, depending what you're applying for. But as a cybersecurity professional, we have to be aware of what we need to protect in the cloud. And it really starts at IAM. But before I get into the nitty gritty, let's go over these key notes. So cloud architecture involves hosting IT resources such as storage, application, servers, our compute, our network, functions now, microservices, and what would be remote data centers that we don't control or own physically or any environmental, and is provided by a CSP, a cloud service provider. These CSPs provide us internet access to a console or portal to deploy, manage, troubleshoot, and scale the resources that we pay the CSP to host for us. So in our cloud environments, we have a lot of different options of how to use those cloud-based services. At the very basic, we have three service models called infrastructure, platform, and software as a service, which pretty much boils down to, when it comes to our security perspective, is what role, what responsibility do we have depending on the services we're using to protect that service, and what falls on the cloud provider. So, first off, if we're deploying, managing, doing all of our cloud infrastructure architecture from a portal, or even from scripting, right? IAC, infrastructure as code using Terraform. First thing we got to think about is IAM, Identity Access Management. We have to secure our credentials to create these cloud resources and manage them. That's step one. That includes who has access to billing, because with the cloud, we call this an operational expense. So we have some FinOps, financial operations in the cloud we have to be aware of, and securing access to that billing. Securing our access to a cloud-based portal or console, or however we do our infrastructure as code, is paramount. That is where I believe the new perimeter is for the cloud. Because cloud-based environments are typically built on a shared infrastructure. Unless we're doing GovCloud or we have a use case for private cloud, which has an increased cost, it's a multi-tenant environment. We're sharing resources with other organizations. So we don't have physical access to the data centers to protect it. We're not creating VLANs to do network segmentation. Now we're doing micro-segmentation. So to bring it all back, one, our IAM has to be secure. Multi-factor authentication, placing the right permissions on whatever teams are accessing the cloud, doing good RBAC, good IAM, just good permissions. Something that was common on-prem, we push that same mentality to the cloud. We're doing RBAC, we're doing the principle of least privilege. Two, we're in a multi-tenancy. We are in a shared tenancy. If I go build a VM and another organization builds a VM in a Google Cloud East region, guess what? That actual VM or whatever resource we create could be on that same physical server. There is segmentation we have to do in the cloud. That involves network and micro-segmentation that we have to be aware of. We call that east to west traffic filtering. Now in Azure, how we would do this is we build VNets, subnets within those VNets that are tied to a physical region, and then we can place network security groups and network security lists or application security list groups on those actual resources via the VNet or the subnet. So we still have a hierarchy in how we apply policy and firewalls and filtering. Another key thing in the cloud is it's public. So if we're building resources with a public IP, we don't want to just put that front facing. We don't want anyone to be able to ping our VM or a resource and see that public IP. We typically want to put that behind some sort of proxy. Now the big three CSPs, AWS, Azure, GCP, all have their way of doing it. But the general consensus is that we place our resources that have to point to the internet, to the public, behind some sort of NAT load balancer, some sort of proxy, some sort of gateway that we can't get direct access to. Hardening doesn't leave us either. Resources in the cloud also have to be hardened the same way our on-prem devices did. We don't want open ports and services. We want to apply those mitigation techniques like ACL filtering like I just described. Security in the cloud also depends on your responsibility. We have these service models: infrastructure, platform, and software. With infrastructure as a service, that's going to give us the most capability to configure things how we want in the cloud. But with that is all the responsibility. So if I'm deploying a VM in the cloud, it's my responsibility to maintain that operating system, patch it, update it, and monitor it. So resources in the cloud, we still have to monitor. There may be some resources, features in the cloud that lets us monitor it natively, but that's still the onus is on us to monitor our connections, to monitor what's happening in that operating system, patch it. That's infrastructure as a service. With platform as a service, this is like databases. This is functions as a service, microservices, something like Vercel, which allows us to deploy an application to. A lot of that security, that responsibility does fall back on the cloud provider, but we still have some onus on that, some ownership. We still have to do the IAM. We still have to make sure that we're doing multi-factor authentication for anyone that can touch our platform that's hosting our application. Then the last service model we're going to talk about is software as a service, where pretty much the cloud does take full responsibility. Depending on what cloud provider you're going with, they have different responsibility matrices. But you still may have to decide on the IAM. Where's the admin account? Multi-factor authentication. And I'll keep beating that like a dead horse because I do believe IAM is like the first perimeter in cloud security. If someone can get access to your console or your credentials gets exploited, sayonara. Keynotes. Don't want to drag on too much. Cloud architecture leverages technologies such as virtual machines, containerization, and automation tools to optimize operations. Some security measures that are included in the cloud are native firewalls. So our firewall services become native in the cloud. It's not a physical hardware appliance. Encryption for data in transit at rest. So like in Azure, we can build our own custom keys for all of our disk allocations. We create a virtual machine or even a container cluster, a K8s cluster. We have that persistent disk space that we can apply full disk encryption on. And then it also gives us the ability to do continuous monitoring as well. There will be some native cloud technologies, measures, features that will allow us to do that. Now, before we move on, I'm going to pause the video. I'm going to log into a cloud console, Google Cloud and Azure, to show you a little bit around it a little bit. So this is GCP. This is the Google Cloud console. And as you can see here, we're just going to quickly go to this VPC network and firewall. Yeah, we'll do that. VPC network and firewall here. Just to show you this native firewall and how we would configure it, our different rules, our policies. We'll probably do some cloud security stuff in some bonus videos. We come here to Azure. Enter ID is where we do all of our identity access management. And Azure is actually, that's my like cloud of choice. Has a good hierarchy in how we apply RBAC and like Azure policy, kind of like almost group policy. But IAM starts here. And then at the actual manage groups and subscriptions, we can actually put IAM policy. So if we come here to like a subscription, let's go to our management groups, actually, the root groups. This is like the top of the hierarchy for an Azure tenant. Tenant root group. Actually, let's just come here. We'll go to this HR one. You see we have IAM here. So any subscription under this HR managed group, we can put different controls. We have different Azure governance we can set here. And then any resource underneath will get that. Okay. Now we're not going to get too complicated here. This is not a cloud course. So we're going to go back to our slides now and move on. So next, hybrid architecture. So everything I just talked about with on-prem and the cloud, you can do both. It is possible. It's not one or the other, and there's not one organization where you just need one. Some maybe small startup. We don't have a really on-prem infrastructure at Trepa Technologies. Our website's cloud-based, hosted by Vercel. But big enterprises, maybe there's still a use case for that on-prem, and there's a use case for utilizing the cloud. And we may have to combine the two. So hybrid architecture combines elements of on-premise and cloud environments, allowing organizations to use both their IT operations. For their IT operations. This model is ideal when certain applications or data need to remain on-prem due to compliance requirements, while others may be suited to the flexibility of the cloud. That is true too. Sometimes we have some compliance that we have to abide by that says we can't host things in the cloud. Or maybe it's capable, but maybe we're not FedRAMP approved for something to work in the DoD or the government network. So a hybrid environment enables seamless communication between on-premise systems and cloud-based resources. Good example here. A financial institution processes sensitive transactions on-prem, but uses the cloud to run customer-facing web services. So that's maybe an example we could use, right? A great example is really, again, back to IAM, but your users. So if you're working in a traditional Microsoft environment with Active Directory domain services and a whole forest on-prem, maybe you do a sync to the Azure cloud. And now Azure Enter ID can also help manage or get push user accounts from Active Directory up, because that's the source, Active Directory. But that's another hybrid use case that's very common in big enterprises that are Microsoft based. Okay, network segmentation. Now, depending where we live, and what I mean by that is if we're on-prem or within the cloud, we still can do network segmentation. The way it's accomplished is very different. In data centers, we have some advanced network segmentation like VXLAN that we can use. We won't get into that. That's not on these exam objectives, so I won't go down the rabbit hole. But in practice, this is just dividing the network into smaller isolated segments to improve security, manage traffic. On-prem, we can apply group policies to a subnet, which equals a VLAN, and that's network segmentation. In the cloud, we can do micro-segmentation. So in software-defined networks, which is what the cloud is built on when it comes to networking, we're talking network architecture here, micro-segmentations allows us to filter east to west. It allows us to put security policies on a per service basis for all these microservices that we use in our modern day web architectures, rather than like an old school monolithic web architecture. So this kind of network segmentation, this architecture, minimizes the potential impact of a breach by restricting lateral movement within the network. So for example, if one of our users falls victim to a phishing attack, maybe they download a worm, with network segmentation, we restrict or maybe isolate that event, and maybe that worm can't self-replicate to other parts of our network. Maybe within that subnet, within that broadcast domain, but maybe not to another VLAN or subnet. So, on-prem, VLANs are a good use case for this. In the cloud, in SDN, software-defined networking, we also have micro-segmentation. Another good example is our wireless. Very, very common when we have a guest wireless network broadcasted with an SSID of corporation-guest, and that's a completely segmented network belonging to its own VLAN that has maybe stricter security policies and obviously no network permissions, right? You don't want someone logging into your guest network and, oh, they can hit our shared drive, look at our accounting and our payroll. And then we have that corporate Wi-Fi that's its own wireless local area network that does give authenticated users access to the full enterprise. Something else we're going to talk about that could be its own hour-long video is Zero Trust. So Zero Trust, it's not a product. It's not something that a vendor can sell you. A vendor may have a product that helps with Zero Trust, but this is a network. This is an architecture. Zero Trust, when it's defined by NIST, you can see it down there, 800-207. It's a framework. It's something that guides you in how to build an architecture that is Zero Trust, that contains a lot of different components. That's not always an all-in-one solution. Sorry to any vendors out there that may watch this that sell Zero Trust solutions. There are components of it that you sell, but to say there's an all-encompassing product is not true. Now back to the exam objectives. This is a framework, and there's some key core principles of Zero Trust. And this network architecture, sometimes we refer to this as ZTNA, Zero Trust Network Architecture. You may see that acronym, ZTNA. But this is a security model, and there's some core principles. The first principle is that it verifies explicitly, meaning never trust, always verify. So when we have a subject, say a user, could be a computer object that's joined to the domain. We'll just stick with the user, a subject. And that subject wants to access an enterprise resource or an object. It has to always, regardless if it's already previously been authenticated and trusted, has to go through what NIST defines as a policy enforcement point. This is high level. This is holistic. If you look up by policy enforcement point hardware, that's not going to work. However your organization authenticates, that's the policy enforcement point. If it's Active Directory, old school Active Directory, then okay. So verify explicitly. Never trust, always verify. So always authenticate and authorize based on all available data points. This brings into a lot of contextual things too. The user identity. So is the username and password correct? Did they do their second factor of authentication? Where are they logging in from? Where are they trying to access from? If it's a location that we may have blacklisted in our policy enforcement point from our control plane configuration, right? As a policy administrator using some zero trust vernacular, do we have to enforce maybe third factor of authentication? The device health, the service or workload may come into account when verifying and allowing the subject to access a resource. Is the resource trying to access extra sensitive? Maybe that's the reason we enforce a third factor of authentication. Another core principle of zero trust that is really it's just good security. We've been doing it since cybersecurity became part of the enterprise is least privilege. The principle of least privilege access. We want to limit user, service accounts, all types of subjects, application access to the minimum resources required for the specific role or task. So if we have a service account that runs our SNMP software, that's all it's going to do. That's all the access it's going to get. If we have a database administrator, senior, that database administrator is going to get access to our databases, and that's it. And of course, maybe some other things, shared drive to, work within a cohesive team and our DevSecOps team. That's the principle of least privilege. Another core value of zero trust. Now, there ain't no product that gives you least privilege. It's something you, the policy administrator, will have to configure in your policy engine, and then that gets pushed down to your policy enforcement point. If you're wondering, I'm looking at this image too when I'm describing these things. We also have things like use JIT, or just in time, or just enough access principles to ensure access is temporary and tightly scoped. In Azure, when you have like a P2 license, you can do this. You can do PIM, Privileged Identity Management, and you can say, hey, this administrator is going to get elevated privileges for this amount of time. So that's like just in time. Another core principle is always assume breach. So now this is getting to the fun part of cybersecurity, not just always policies and permissions and multi-factor and contextual things. This is always assume breach. Design the system to always be breached. So you may say, what does that mean? That means if you have to deploy a web server, you want to limit its exposure if it is breached. Put it in a screen subnet or DMZ. Put it in its own VLAN. Give it its own isolated environment that still allows high availability. Design the system to limit the blast radius of any potential breach. You also want to monitor and analyze consistently for any anomalies. This is a lot easier nowadays with machine learning and AI. We can implement large learning models and let's just say an inline on-prem firewall that creates user baselines, and then we establish that baseline, and now we use that AI or that ML to alert us when there's any deviations, and it will quickly alert us. And then from there, we have to set our severity scores and how we want to be alerted. Is a SEV1 a major deviation with suspected data exfiltration? We get called, we get Slack message, we get emailed to everyone, not just the on-call guy. So always monitor and analyze for anomalies, continuously to detect potential threats and mitigate them quickly. So that's the 3 core principles, just to reiterate. Verify explicitly. Never trust, always verify is how I've heard it. So never trust, always verify. Least privilege access. So principle of least privilege. And always assume breach. Some other key components that I spend a lot of time on of zero trust network architecture is, of course, having good IAM, maybe a centralized authentication system that's performing RBAC and doing the principle of least privilege, and maybe some attribute-based controls as well. Microsegmentation. We always want to divide our network into smaller zones, each with its own security controls. That reduces our blast radius for, if there's a breach. Device security. Have hardened devices. Have XDR or EDR, which stands for Endpoint Detection Response or Extended Detection Response, on the actual host devices. Don't get caught up in your whole network and forget about hardening your host. We can have something like Secure Access Service Edge or SASE, which we're about to learn about, that combines wide area networking with services like secure web gateway and cloud access security brokers. And that gives us our single pane of glass appliance that allows us to monitor our network holistically for all of our remote workers, our enterprise workers, our resources in the cloud. And then, of course, put encryption everywhere. Anywhere you can, always put encryption. Okay, moving on. So we just touched on this. Oh, sorry about that. SASE. I love the way that's pronounced. Sometimes anyways, a little dorky, but yeah, SASE. This is a cloud-native framework that combines networking and security services into a unified architecture. I have a Cisco image up there. I come from a Cisco background when it comes to networking. But Cisco SASE, that's combining the Cisco security umbrella, the Cisco Duo, and Cisco SD-WAN into a single unified platform, which gives us that single pane of glass, which can also help our SOC team, which is us, the CYSA certified individuals. And now we can use that SASE, maybe webhook it to a Splunk, our SIM or SIME system, and now we do log data aggregation from that single pane of glass, which can really help us with our monitoring, our indexing of important information. But SASE, get back to it, integrates technologies like SD-WAN, software-defined wide area networking, secure web gateways, which is like very similar to web application firewalls, but for the cloud. It goes a little bit deeper into that packet inspection. Cloud access security brokers, CASB, that's an appliance that can enforce what you had going, the security policies you had on-prem into the cloud. And then, of course, gives you the ability to do zero trust network access. SASE enables organizations to secure access for users across different locations, including remote workers, branch offices, and on-premise environments. Like I said, kind of giving us that all-encompassing appliance for authentication, authorization, and it lets you simplify the management. And then the last thing we're going to talk about is SDN. So SDN, software-defined networking. Really the best way to talk about software-defined networking is to show you what traditional networking looked like. So let's do it. I'm going to go into Secure CRT right now to show you what traditional networking looks like. So to define SDN, I want to show you its older counterpart, traditional networking. If I want to manage, monitor, a network switch in traditional networking, I can implement things like SNMP, but this is where it's at, the CLI. You SSH into a device, and if I want to configure a VLAN, so I want to configure VLAN 200, that's the command I use. And we would have to do that for every single device in our enterprise, SSH into it to configure. Obviously, we have infrastructure as code, but that's not traditional networking either. So with SDN, this isn't going away 100% necessarily, these network fundamentals, but it allows us as network engineers to look at the network as a single pane of glass, consider it a fabric with an underlay technology connecting it to our overlay, and we get to manage that entire enterprise network from a single console and also send API calls to it from our HMI, our human machine, which is just a computer, HMI, human machine interface. And that is SDN. In the cloud, all networking is considered SDN because you're configuring network services and resources from a single console as well. Now, how do we look at SDN from the security's perspective? So since we have that centralized control of all policies, routing, configuration for our entire fabric, we have to again look at where we fit in as security. So if we have that centralized control plane, well, there you go. We have to make sure our IAM is good there. We have to ensure that even that the encryption, the IPsec tunnels in like an SD-WAN environment are configured correctly and are in compliance with whatever industry we have. So from a SOC analyst perspective, we like SDN, but there are some other vulnerabilities we have to think of. Because there's so much more interaction between a single controller and a fabric, it kind of leaves that single point of failure. Now, obviously, we have redundant high availability deployments with our single controller. But again, if someone breaches that console and that account, they have access to our entire network. So that's something we have to think about as SOC analysts when it comes to SDN, even though it does simplify the management, deployment, and monitoring for the network. Okay, now let's go ahead and do our quiz. Okay, so we're at our learning management system and our CYSA course, and now let's go do our quiz. So I'm gonna click lessons here. We're still building, so we're gonna go to domain 1.1.2, and we're gonna hit take domain quiz. Now let's do some of these questions. So question 1, in a hybrid architecture, how do on-premise systems and cloud-based systems typically communicate securely? So how can cloud-based systems and on-premise systems, so your on-prem data center and the cloud, talk securely? So we can use VPNs like IPsec tunnel, or we can have a dedicated link there called a direct connect link. Pause the video if you'd like to read the explanation. Question 2, which of the following best describes the purpose of network segmentation? So network segmentation, whether it's microsegmentation, utilizing VLANs to do logical segmentation on your on-prem, it's to isolate segments of your network, and then when you do that, you can start applying security policies to those isolated segments, doing more granular controls like with network security groups, network security lists in the cloud. So I'm going to go with A. It also stops lateral movement. So one of the steps in like penetration testing, or if you're getting hacked and exploited, is pivoting or lateral movement. If you exploit a system, like maybe a printer, something that's kind of low threat, the next steps is to pivot and to do privilege escalation. Pause the video if you'd like to read the explanation. Question 3. What is the primary characteristic of an on-premise architecture compared to other network architectures? So on-prem, that's where you have full control, full responsibility, and everything you have everything you own, you have to do from the bottom up. Power, HVAC, redundancy, all the security, the management, the deployment, the environmental controls. So it's not hosted on third-party servers. It should be on your physical premise. Network traffic by default is not segmented. Like that's not like, oh, that all on-premise has to be like that. And this D describes more cloud-based architecture. So we're going to go with B. All IT infrastructure is managed and hosted within the organization's physical premises. Pause the video if you'd like to read the explanation. Question 4. What is the primary goal of a zero-trust security model? The primary goal. It's not A, because we never assume, we never trust. We always verify, so verify explicitly. So it's not A. We don't assume all devices in the network are trustworthy. B, to dynamically allocate resources in a cloud-based environment. That's not part of zero trust. That's just cloud-based computing, administration, engineering. C, to continuously verify user identity and device health before granting access. That is one of the core principles and tenets of zero trust. So that could be a primary goal. Then D, to separate data and control planes for centralized management. Now, zero trust will separate control plane versus data plane functions, but that's not the main goal. This kind of describes software-defined networking or like software-defined wide area networks. So I'm going to go with C, to continuously verify user identity and device health before granting access. All right, we got that 100%. So I want to thank everyone for viewing. Make sure you like, subscribe, share with your friends, and I'll see you in the next video as we finish up domain 1.1 of our free and full CYSA course.